All right, everyone, welcome to our last geometry lesson of the year. So last shape that we have to solve the volume for is a cup. Now, in here, we call this cup a truncated cone. And the reason why it's because it's made up of two cones when we just kind of think of the one shape. So again, I'm kind of focusing in on finding this volume right here. So think for a second, what strategy might make sense for us to find the volume of that cup? Well, again, since it's called this truncated cone, we know that that cone is there as a little hint. But really, as the other kind of strategies we've used in here, it's like we could take the big cone, subtract the small cone. And if we do that, then we're able to calculate what that volume of the cup would be. So we'd find the volume of each separately and then subtract. Kind of like what we've done in previous units or lessons throughout this unit. So in order to do that, we know our cone formula is 1/3 pi r squared h. So really, the information we really need is the radius and the height. If we have those two measurements, then we're good to go. So let's look at this exercise 3. Say we have the following cup, which is 16 centimeters tall, that has a radius of 7 centimeters and a smaller radius of 3 centimeters. Find the volume of the cup to the nearest cubic centimeter, then show the work that leads to your answer. So, like I said, let's get that volume of the big. So we have 1/3 pi, and we're going to fill in for r and h. So over here, the radius of the larger cone is 7, and the height of that larger cone is 28. So I'm looking at 7 squared, which we know is 49, times 28, and then all divided by 3. So in that case, we're going to end up having a decimal. So when we have that decimal, I'm just going to plug this right into my calculator. And we got basically 1,372 all over 3. So, and of course, you could plug this all in if you want to. Since we're going to round our answer to nearest cubic centimeter anyway, I could plug in the divided by 3, plug in pi. That would be fine. But I'll come back to it in just one moment. Because now we also have the small cone to worry about. It's the same volume formula. They're just going to have a different radius and height, right? Because my smaller radius now is 3. My height here is 12. So when I plug this in, we're looking at 9 times 12 times 1/3. I'm looking at 36 pi. And so the last thing we need to do is subtract those two values. So at that point, it's totally easy to plug it right into our calculator. And I'm going to go ahead and plug that all in. And we should end up 1,323.6577. And when it says to the nearest cubic centimeter, I'm going to shrink some stuff in here so I have some room just to write our final answer in. But 1,324 centimeters cubed. And that's it, right? So that's how we'd find the volume of our cup, which makes sense. So I just wanted to look and investigate something else about this relationship here. So find the ratio of the two cone heights in simplest form. So let's just say I did big over small. So I'm only focused on the height for a moment. So the height is 28 over 12. And when I simplify that as much as I can, again, I could plug this into the calculator, but in this case, that just simplifies to 7 over 3. This ratio, though, is the same as the radii. So let's look at those radii. The small one is 3. And the large one is 7. So here is my height. Here is my radii. Those are the 2 dimensions I need. But notice, in these 2 cones, they're both in the same proportion. So this ratio should make sense to us, though, because they're similar. Now let's talk about why they're similar. First off, it's a cone. So we know it's got a base that's a circle. And we know that all circles are similar. We've known that. We've talked about that throughout the circle unit, right? They all have the same degrees. So really, they only have the radii to compare to. So in this case, that's 7 out of 3. They're just in that ratio. However, the heights now, depending on the way they are, they're connected to that radius to form the cone. So there's only 2 units in there. As long as it's a right cone, meaning it's making a right angle, like the radius and the height make a right angle together, we're going to have similarity there. Okay, it all stems from having that circular base. But basically, we know that this is the same ratio. These cones are similar. And now this is important information for us, because if I'm trying to find the volume of any cup, the realistic part of that is that there's no bottom piece to this, right? If I was in my cabinet and looking at finding the volume of this cup, we don't have an actual cone sticking out, right? Like we don't really always see that there. So because that's not realistically for us to have, one measurement that's given of the measurements given this problem, which one is not realistically not known, we probably won't know the small cone. And we could find part of it, like we would have its radius, but not its height. Because if it's a cup, we know a cup would look more like this. And of course, we can extend this in, but that bottom piece won't be there. So, in the next one, in the following cup problem, a cup with a height of 18 centimeters has a large radius of 4.5 centimeters and a small radius of 3 centimeters. Set up and solve an equation that we could use to find the height of the smaller cone. Well, in this case, when I go to set up my proportion here, we know they're similar. So we can set up in a bunch of different ways, but I know my radii are going to be proportional. So I'm going to have 3, and notice that's the smaller radii, and the 5.4 is the larger. So I don't know what x is, but the larger height's going to involve that and be x plus 18. Keep that in mind, right? It's not going to be just 18. It's not that portion. So it comes back to triangle similarity for us. So we can kind of see that right triangle situation here. And then we cross multiply. So when I cross multiply, I'll have 5.4x equal to 3x. Be sure here that you're distributing. So it's plus 54. So I'm subtracting the 3 from both sides to get 2.4x equal to 54. And then we will divide 54 by 2.4. And I'm going to end up with 22.5. So the height of the smaller cone is 22.5 centimeters. So now we're asked if 1 liter is equivalent to 1,000 cubic centimeters, can this cup hold more than 1 liter? Well, to do that, it's a hint to us that we're doing volume, because as soon as you see any of your units cubic, it means we're going to find volume, but we're trying to find the cup, right? So we do the same thing we did on the other page. So we're going to do the volume of the big. So the volume of the big is going to be the larger radii, so 5.4. Ooh, I forgot to include pi there for a moment. Sorry about that. I could have stuck it on the end since it's commutative, but just out of habit. 1/3 pi r squared times h. The height of the big one now, remember, is the 22.5 plus the 18. Like, this is x. So I'm looking at 40.5. I'm going to plug that whole thing into my calculator just as is. So I'm looking at 1/3 pi r is 5.4 times 40.5, 1,236.719. And our small cone, 1/3 pi, r in this case was 3 squared times h is just the smaller cone, so 22.5. And that's going to be, when I plug that all into the calculator, 1/3 pi, 3 squared, 22.5. I get 212.0575. And to find the overall volume, we subtract those two values. So if you did it right in your calculator, you should be able to pull that right in and subtract them both. And I get 1,024.661686. And now the question is, if it can hold 1,000 cubic liters, so 1 liter is equivalent to 1,000 cubic liters, can this hold more than 1 liter? Well, just by looking at it, we can say yes, right? Because we can see that this number here is over 1,000. If you wanted to, you could divide by 1,000 to get it into liters. If we do that, I'm looking at 1.024, right? So yes. So finally here, like we were talking about, similarity is the key to solving these cup problems. So if I give you these dimensions, why don't you pause the video at this moment just to see if you could do it on your own. Keep in mind the volume formula involves radii. Think about what you have in this picture and set up your picture. So go ahead and pause the video and then we'll double check our answers. So welcome back. If you went through and solved for that volume of the volume of the cup, first you had to do similarity. Now I used the radii, so I used 4 and I used 2.8. If you use the diameter, you would have gotten the same thing. So 8 and 5.6, they're going to be in similarity as well, because if you think about it, the radius and the diameter are similar because they're in that 2-to-1 ratio. So if you use the diameters, that's fine, as long as you didn't use the diameter in the volume formula itself. So if you used 8 and 5.6 for the similarity piece, you should have still ended up with x equal to 35. So that small cone's height would have been 35. Then we go and plug into the large cone. So 1/3 pi, 4 for the radius. That part you can't use the diameter. 50 because we add up the 15 and the 35. And we plug that right in. I did the same thing for the small cone, which isn't technically there shown, right? But we know there would be like a drawn in cone situation over here. So in that sense, 1/3 pi times 2.8, I cut that 5.6 in half, times 35, subtract the 2, you should end up with 550 cubic centimeters. All right, guys, enjoy this video. Hope you enjoy your last new lesson on geometry. And then I will see you guys in our next class. Thanks.